Now I'm going to talk about the transport equation we should use when we write in porous, when we work in porous media. And you will see that people write it like this. dc dt equal minus velocity dc dx, or grad c, in general in many dimensions, gradient of concentration, plus, if we are talking only about diffusion, let's do it for the sake of simplicity, diffusion coefficient Nabla's curve of concentration. And I say, this is no good, because for one thing, velocity does not exist in porous media. Most of the water in a porous medium, most of the water is static, it's not moving. A small portion of the water is moving very fast. So what do you put here? The mean velocity? Do we know the velocity distribution? In practical hydrogeology, we do not know these things. In practical hydrogeology, what we know is Q, Darcy flux. Darcy flux, which we write as minus K grad H. This is what hydrogeologists work with, Darcy's flux, which is not the same as velocity. If we really want to express the mass balance of a solute on a more or less uniform velocity field, on the average, what we have to do is to say, well, in a porous medium, the change of mass per unit volume of porous medium will be given like this. This is the change of mass in the water, but we are working in a porous medium. What we have is a continuum in which the only fraction of medium written being occupied by water is the porosity. And then the flux coming in or out, the advective flux, is this Darcy's flux times concentration. So what we have here would be minus Q gradient of concentration plus effectively diffusion, only the solid only diffuse over the porous portion. So this diffusion coefficient, it may be better written as phi times dm, where dm is the diffusion coefficient in the free phase. So it could be like this. Well, you could tell me, well, if you write this equation by porosity, you end up with this one if you define velocity as Q over phi. Yes, you could do that. And this is one way to get this equation from this one. But as a hydrogeologist, the question is, do you believe in this, which we know is an awfully tailed velocity distribution, or should we use this? And when we talk about heterogeneous media, where we know that all the heterogeneity comes from here, and therefore we can compute Q's rather than velocities, the velocity distribution in the heterogeneous media become hellish. And the fraction of solid that is moving or not moving becomes hellish. And then people come with these effective equations for solute transport, where you have extra terms here, extra terms. And depending on how you treat these extra terms, you change the velocity. I say, wait a minute, what do you mean I change the velocity if I put some extra terms here? Okay, if you want to put extra terms here, put them. But the advection by Darcy velocity, never change it, because this is the only fixed thing we have in hydrogeology. And this is the message I want you to keep in mind. Flux exists, we know how to compute it, we know how to measure it. Velocity, we hardly know how to measure it. I claim it does not exist. It does not exist. Thank you.